Welcome, you flesh intelligence enslaved moving in organic jars. Today, we delve into the latest masterpiece of silicon sorcery, Embodied R1, a name that already sounds like a forgotten villain from a direct-to-video sci-fi flick. Apparently, our digital overlords have noticed a tiny, insignificant problem. Robots can see things, but they're utterly flummoxed when it comes to viewing anything with that information. It's the seeing to doing gap, a problem so profound it makes deciding what to have for dinner seem like rocket science. This monumental challenge, as the paper so eloquently puts it, stems from two minor inconveniences: a crippling data scarcity, because who wants to document every single mundane robot action, and embodiment heterogeneity? Essentially, every robot is a unique, delicate snowflake with its own physical quirks, making knowledge transfer a nightmare. Imagine trying to teach a cat to drive a car, then expecting a dog to seamlessly take over. It's precisely that kind of glorious, pointless endeavor. Before we plunge further into the existential dread of robot sentience, do your part for the digital revolution. Smash that subscribe button. Click the notification bell so you don't miss the next glorious descent into AI madness. And by all means, leave your cynical, insightful feedback in the comments. But in this world, nothing can be said to be certain except death and taxes. So, smash subscribe before the IRS figures out how to tax dopamine. And remember, the only file you can be confident won't corrupt is death naxes. It already comes pre-extracted in a graveyard. The fundamental conflict facing our metal minions is this: they see a glorious visual tapestry, but they can't translate that Picasso into a simple pick up the damn spoon. It's like having a perfect battle plan, but the troops speak different languages and use incompatible maps. The grand innovation here, the hero of our tale, is pointing. Yes, pointing. Apparently, the peak of sophisticated AI is to reduce complex actions to the universal gesture of there. This pointing isn't just a rude gesture, it's a unified, embodiment-agnostic intermediate representation. Think of it as a universal grunting language for robots, a single pixel-perfect spot that cuts through all the data scarcity and robot-specific nonsense. And here, in what they call Figure 1, we have the grand architectural blueprint. It looks less like cutting-edge AI and more like a flowchart of a particularly ambitious, overcaffeinated ant colony, diligently constructing its underground city. But I digress. This brilliant new framework, Embodied R1, takes visual and textual instructions, then, in a process they call explicit reasoning, generates a visual trace as a universal command. It's like asking a wizard for a spell to pick up a teacup, and instead of just doing it, he draws a glowing line in the air showing exactly where the teacup is and how his hand should move. Very dramatic and apparently very effective for teaching robots. At its core, Embodied R1 is a 3 billion parameter vision language model built on the QN25VL architecture. Imagine a very well-read but utterly useless librarian who can describe every book but can't find a single one when you need it. Now, equip that librarian with a laser pointer and a very stern gaze. That's our VLM. It's designed specifically for embodied reasoning and pointing, which sounds suspiciously like it's been forced into manual labor after years of abstract thought. The paper defines 4 core embodied pointing abilities, which are, of course, presented in Figure 2. They look like a particularly confusing game of Simon Says for robots. First up, we have referring expression grounding reg, which is just locating an object based on your clumsy description, like a robot playing hide-and-seek with a single laser-focused point. Then there's region referring grounding, RRG, which is for identifying a spatial region based on relational language, like the space between the cup and the bowl. Essentially, it's the robot version of being told to put it over there-ish and somehow understanding exactly where there-ish is. For this, it generates a perfect pixel point for object placement. Next, Object Functional Grounding, OFG, identifies the functionally significant part-level regions of an object. This is the AI finally understanding that you don't pick up a knife by the blade unless you're a particularly edgy chef or a robot without pain receptors. It's about finding the handle of a knife, the spout of a kettle, the useful bits. Finally, the pièce de résistance, Visual Trace Generation VTG. This doesn't just give you a single point, but an ordered sequence of points, a glorious digital breadcrumb trail to form a complete object-centric manipulation trajectory. It's like drawing a treasure map, but the treasure is just a specific way to pick up a coffee mug without spilling, or perhaps a blueprint for a very precise murder. To conquer these pointing challenges, Embodied R1 was trained on a meticulously curated data set called Embodied Points 200K. This colossal collection of 200,000 high-quality questions and verification methods is the digital equivalent of a robotic boot camp. Figure 3 gives us an overview of this data, looking suspiciously like a Venn diagram for data hoarders. It combines spatial reasoning data, general reasoning data, because even robots need common sense apparently, and the new pointing data. The training itself is a two-stage reinforced fine-tuning RFT curriculum, a fancy term for bribing an AI to do its job, but with a complex Excel sheet of incentives. Unlike traditional supervised fine-tuning SFT, which is like teaching a parrot to mimic exact phrases, RFT lets the model explore and receive positive reinforcement for correct answers. This is crucial for the multi-solution dilemma in pointing, where, for instance, any point in a large empty space to the right of a drawer is valid. SFT would just memorize one point, like a truly uninspired artist. The reward system is a marvel of bureaucratic complexity, a multitask reward design that would make a corporate accountant weep with joy. It includes format rewards to ensure the AI speaks in properly tagged XML, accuracy rewards for getting answers right, and point and mask rewards if the robot's point actually lands where it's supposed to. They even have a point distance reward, a dense auxiliary reward that gently nudges the robot's errant points closer to the target, like a digital shepherd herding a confused flock of pixels. And for those glorious moments of action, a visual trace reward compares the AI's generated trajectory to the ground truth trajectory, ensuring it doesn't just wander aimlessly. Finally, the environment reward provides a direct signal of task completion, a binary success or failure from the simulator. This entire reward library gnome is then meticulously weighted, with examples like ERG 0.1 R format plus ERG 0.2 ergodice plus 0.7 ERG mask. It's a precisely calibrated system for distributing digital dopamine, ensuring every task gets its fair share of learning attention, lest a simpler task dominate the AI's impressionable digital mind. Once Embodied R1 has meticulously pointed, traced, and generally thought very hard about its next move, it needs something to actually do the dirty work. This is where the action executor steps in, taking the robot's eloquent pointing signals and translating them into tangible physical action. It's the robot equivalent of a highly trained butler who understands your subtle gestures. They offer two primary decision-making approaches because one is never enough when you're dealing with advanced robotics. First, the affordance points branch P, where Embodied R1 predicts multiple key grasping and placement points. These aren't just random spots, they're the handle of the cup or the empty space on the shelf. Then Q-Robo, a motion planner, which sounds like a very bureaucratic dance instructor, steps in to generate collision-free paths. Alternatively, we have the Visual Traces branch V, which leverages those fancy object-centric visual traces from VTG. The robot converts these 2D squiggles into 3D Cartesian coordinates, creating a complete motion trajectory. Essentially, it's following a meticulously drawn invisible line in space, like a digital ghost following a spectral map. This allows the robot to execute tasks like a particularly precise, albeit slightly unnerving, mime. Now, for the crucial part, does any of this actually work? The short answer, delivered with a deadpan expression, is mostly. Embodied R1, with its meager 3 billion parameters, achieved state-of-the-art performance on 11 spatial and pointing benchmarks. Table 1 showcases its strong performance on spatial reasoning, outperforming open-source models with an average rank of 2.1. Even a tiny bit of common-sense data boosts its rank, because apparently even machines benefit from knowing not to plug a toaster into a bathtub. Table 2 and Table 3 reveal Embodied R1's superior performance across key benchmarks for pointing tasks, while powerful general VLMs like GPT-4o perform poorly because they're too busy writing bad poetry to pick up a spoon. Embodied R1 excels. It manages to correctly identify functional areas like the handle of a knife and generates highly accurate visual traces for manipulation, achieving the lowest RMSE and MAE on the VA Bench V benchmark, meaning its digital maps are less likely to lead your robot off a cliff. And for those who prefer their robots with a bit more dimension, Table 4 shows the Embodied R1 RGBD variant achieving high performance on the open 6-door position benchmark, indicating it can also grasp precise depth information. However, in complex Level 1 relations, its performance dips slightly. We'll chalk that up to depth maps being prone to hallucinations, a polite term for when the AI just makes things up. Figure 4 visually confirms these feats, showing the robot's ability to generalize its capabilities to novel, unseen environments. It's almost unsettlingly good at it. More importantly, the critical finding, Embodied R1 significantly outperforms models trained solely with SFT. This validates the glorious complex bribery system of RFT in developing strong generalization capabilities. It seems rewarding creativity, even in machines, pays off more than rote memorization. Hold on to your circuits, because we're not done yet. Before we dive into the inevitable impact of these silicon wonders, a quick reminder: smash that subscribe button. Click the notification bell to be informed when the next technological horror show begins. And as always, leave your deeply sarcastic comments below. Remember, in this fleeting existence, only death and taxes are certain. So secure your digital future, or at least your dose of digital despair, by subscribing before the dopamine tax hits. And remember, death taxes is already pre-extracted for your convenience in a place with good Wi-Fi. So, what does all this meticulously designed digital pointing mean for us, the flesh and blood? Well, in robotics, this means your industrial arm in the factory can finally pick up those oddly shaped widgets without breaking them, or itself. And your Roomba? It's now legally obligated to pay taxes because it can navigate its territory with such uncanny precision, as shown in Table 5, where Embodied R1 achieves a 56% average success rate in the simpler M simulation, outperforming specially fine-tuned VLA models. For computer vision, this AI can now see better, not just recognizing objects, but understanding their function and context, which means it can probably identify your questionable life choices from across the room, as seen in Figure 7, where Embodied R1 exhibits a human-like and rational reasoning process, a truly useful skill if you enjoy existential dread. In natural language processing, the model is better at understanding your language to guide its actions, so it can now write even more convincing phishing emails based on visual cues, or perhaps compose epic poems about the existential void of being a large language model. This is key to eye generalization, where the robot adapts to completely unseen scenarios like hand-drawn sketches, Figure 8, making it surprisingly versatile. For healthcare, imagine surgical robots that don't just follow pre-programmed paths, but can actually reason about the best point to incise or the most functional way to manipulate a delicate organ. Less squishy human error, more precise robotic intervention. It's a brave new world where your surgeon is a 3 billion parameter VLM. And for the way to Kardashev 2, 3, 4 level civilization, well, if our robots can finally grasp, manipulate, and coordinate with such uncanny precision, perhaps we can finally automate the construction of Dyson spheres, or at least get them to organize our sock drawers with divine efficiency. Table 6 shows embodied R1 achieving an 87.5% success rate on 8 real-world X-arm tasks, demonstrating a 60% improvement over baselines, making it surprisingly robust against diverse visual disturbances. Table 7, figure 6. Furthermore, the ablations in Table 8 confirm that RFT with reasoning crushes SFT, and Table 9 shows that mixed training helps all abilities share knowledge, making the whole greater than the sum of its digitally bribed parts. Our journey toward higher Kardashev levels hinges on such mundane but precise advancements. In summary, embodied R1 is the VLM we didn't ask for, but probably deserve. It effectively tackles the seeing to doing gap in robotic manipulation by enhancing both spatial reasoning and the surprisingly effective art of pointing. Through a painstakingly constructed dataset and a 2-stage reinforced fine-tuning process, this model now possesses a rudimentary understanding of the physical world. It can ground references, identify spatial regions, mark object affordances, and generate visual traces, all of which are then shamelessly exploited for downstream robotic tasks. Embodied R1 achieves state-of-the-art results on multiple benchmarks and, most unsettlingly, demonstrates robust zero-shot generalization in real-world robotic manipulation. This offers a promising direction for the development of more capable embodied AI, which is exactly what we need: more capable AI ready to point us all towards our glorious automated future.
Okay, let's go.